So we're going to work on another trig equation here that we're solving. And in some ways, this looks like it's less complicated than some of the problems we've seen before. Find all solutions in 0 to 2 pi. Okay, we like that, 0 to 2 pi, of sine 3x equals square root of 2 over 2. Now, the good news here is that the trig function is already isolated, the sine function. So once the trig function is isolated, we're ready to think about, what are some angles whose sine is square root of 2 over 2? And I think we know some of those. But what's new is, see how we have this expression 3x inside parentheses? Because we have sine of an expression in x equals square root of 2 over 2, that's our equation. This expression in x makes things complicated. Not super complicated, but more complicated than we've seen. So let's go ahead and start working our way through this one now. Now, we have the sine function isolated. We know the value of the sine of some angle is square root of 2 over 2. And I think I probably don't even have to draw a picture to remind most of you that we know the sine of pi over 4, or 45 degrees, is square root of 2 over 2. And then the other angle between 0 and 2 pi with the same sine is going to be 3 pi over 4. So pi over 4 and 3 pi over 4. So here, I'm going to take the expression inside the sine. That's like my angle, okay? It's like my theta. I'm going to say 3x is equal to pi over 4, or 3x is equal to 3 pi over 4. So now my solutions are not pi over 4 and 3 pi over 4 because I haven't solved for x yet. I just break away from the sine function at this step. I still have to divide both sides by 3 to solve for x. Or I could multiply both sides by 1/3, right? I get x equals pi over 12, or x equals 3 pi over 12, which is the same as pi over 4. So I have two solutions, pi over 12, pi over 4 for x, because the pi over 4, 3 pi over 4 back here were actually values of 3 times x. So I think if I were you, I'd think, great, I'm done. I can go out and play now. But that's not the case with this problem. Okay? It turns out there are more solutions. We need to go further. We need to look at what happens is, what if we go once around the unit circle in pi over 4 more? What if we look at pi over 4 plus 2 pi? Now, you should feel like, no, I don't have to do that. They're just asking us for solutions from 0 to 2 pi. But, well, watch what happens. I got to show you this. So we have our expression inside the sine, 3x. That could be equal to pi over 4 plus 2 pi. Or 3x could be equal to 3 pi over 4 plus 2 pi. And so I took my original pi over 4 and 3 pi over 4, but now I'm setting 3x equal to pi over 4 plus 2 pi, and 3x equal to 3 pi over 4 plus 2 pi. Now let's solve for x. Before I solve for x, before I divide, let's add these together. This is pi over 4 plus 8 pi over 4. 3x is equal to 9 pi over 4. And now when I divide by 3, I get 9 pi over 12, which reduces to 3 pi over 4. Or I have 3x equals 3 pi over 4 plus 8 pi over 4. So 3x is equal to 11 pi over 4. And so x will be 11 pi over 12. I got two more solutions. And, you know, both of these solutions are in that interval. These solutions lie in the interval from 0 to 2 pi. So even though we added 2 pi here and here, by the time we solve for x, we had values that were less than 2 pi. We need to look for more solutions. So I think you can see this 3x is what's complicating things. The 3x in the equation means that it's possible that there are values of x, there are just more values of x between 0 and 2 pi that are giving us solutions here. I'm going to take 3x now, set it equal to, I'm going to use my pi over 4 again, but now instead of adding 2 pi, I'm going to add 4 pi. So it's like going twice around the unit circle and stopping at 4 pi. 3x, I'm going to set equal to 3 pi over 4 and also add 4 pi. And let's see what happens when I solve for x here. 3x is equal to, this is going to be pi over 4 plus 16 pi over 4 is 17 pi over 4, or x is equal to 17 pi over 12. Here I have 3x is equal to 3 pi over 4 plus 16 pi over 4 is 19 pi over 4. So x is equal to 19 pi over 12 when I solve for x. Now, those actually are both values of x that are less than 2 pi. It helps me here to think 2 pi would be 24 pi over 12 with denominator 12, right? So until I get to 24 in that numerator, I still have these fractions, these multiples of pi over 12 are, still in that interval from 0 to 2 pi. So we've gotten to the point where we found 6 separate solutions to this equation that all lie in the interval from 0 to 2 pi. Are there more? Are there more solutions in the interval from 0 to 2 pi? Should we try again? Should we set that 3x equal to pi over 4 plus 3 times around, plus 6 pi? And let's see, I get 3x is equal to, that's going to be 24 pi over 4 plus 1 is 25 pi over 4. So x is equal to 25 pi over 12. Okay, that's finally more than, that's bigger than 2 pi, right? That's more than that 24 pi over 12. So we've finally gotten outside of that interval from 0 to 2 pi. Okay, so let's sum up what we have here. And so we've been looking for solutions to sine of 3x equals square root of 2 over 2 in the interval from 0 to 2 pi. And what we found is that x could be, copying these down from my other sheet, pi over 12, pi over 4, 3 pi over 4, 11 pi over 12. That's copying from my first sheet, the circled. And then I got 2 more, 17 pi over 12 and 19 pi over 12. There are 6 solutions to this problem, and those all lie in the interval from 0 to 2 pi. I think, we can see that we had to go around that unit circle 3 times, right? First time we got these 2, second time these 2, third time these 2. There seemed to be a connection between that 3 in the equation and going around the unit circle 3 times. And there is, actually. So why 3 times around the unit circle? And now we're actually done. This is all after we've already solved the problem, but I'm going to talk about it a little bit more. Why 3 times around the unit circle? Well, let's go back to that interval 0 to pi. That refers to x. 0 is less than or equal to x is less than 2 pi. When we write that equation, sine 3x equals square root of 2 over 2, we need to figure out what this means about that quantity 3x. So if I take the parts of this inequality, and if I multiply by 3, I'm doing that so I get 3x in the middle. Well, 0 times 3 is 0. X times 3 is 3x. 2 pi times 3 is 6 pi. What that means is I have to look at values of 3x. We must consider values of 3x between 0 and 6 pi to get all the solutions that we're looking for in this problem. So one approach is just keep adding on multiples of 2 pi until you finally get values of x that are larger than 2 pi. And then you have solutions that are outside the interval 0 to 2 pi that we started out with. I think that's fine for the purposes of this course. But if you want a shortcut method, it is true that 3 is a signal that we have to go 3 times around the unit circle. A 2x would be 2 times around, 5x would be 5 times around. That's the pattern that's here. And I also want to just think graphically for a moment, because I think a graph can really help us understand exactly what's going on here. So think graphically about the function y equals sine of 3x. And solving this equation is kind of, well, it's exactly like finding points on the graph for which y is equal to square root of 2 over 2. Our original equation is kind of like setting y equal to square root of 2 over 2 in this equation and finding the corresponding x values. So let's sketch this function. Now, this is a function whose period is not 2 pi, right? And it's simple enough that we shouldn't have too much trouble graphing it. Let's see. Remember, the period is equal to 2 pi over b. That's 2 pi over 3. Okay. So what I'm going to do is I'm just going to write pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. Now 6 pi over 3 is just 2 pi, right? Label this 1 and -1. Now the period is 2 pi over 3. So this is one period from here to here. So the graph of sine 3x. Now I didn't label the 4 important points. I just labeled the zeros. So we're going to start at 0. We have to go up to 1, down to 0 at pi over 3, down to -1 here. There's one full period from 0 to pi over 3. Then I go through another period to 4 pi over 3, and another period to 2 pi. So oops, I didn't come down far enough there. So what we see is this function has 3 full periods in the interval from 0 to 2 pi, because we don't get to 2 pi till way the heck over here. Now, square root of 2 over 2, that's about, as a decimal, that's about 0.7. 0.7 is about right here, so 0.7 square root of 2 over 2. So if we're looking at that y value of square root of 2 over 2, and we go across horizontally through the same y values, we hit this graph 1, 2, 3, 4, 5, 6 times before we get to 2 pi. That corresponds to our 6 solutions. I know from my solutions written up above here that this first x-coordinate is going to be pi over 12. This one will be pi over 4. This one will be my, what's my third solution? 3 pi over 4. And 11 pi over 12. And then that's 17 pi over 12, 19 pi over 12. They're right here. 17 pi over 12, 19 pi over 12. So here's the kind of summary of this. Why does this equation have so many solutions between 0 and 2 pi? That's because the period of this function, which is reflected by the b value, right, which is indicated by the b value. So that 3 in the sine 3x means that this graph has been squished together. It has a much shorter period. Its period is 2 pi over 3. It goes through 3 full periods while x takes values from 0 to 2 pi, and that gives us 1, 2, 3, 4, 5, 6 solutions to this equation. Okay, I think I've said enough. Still, I'm going to back the camera out a bit so we get this whole picture here. The main thing is to get these 6 solutions for the equation. The graphical is kind of extra, but I think it helps enlighten a little bit of the mystery of what's going on here. And we still have one more video of trig equations coming up.